When we think of medieval castles, we often imagine stone walls, roaring fires, and knights in shining armor. But what about the basic necessities, like water? Without modern plumbing, how did castles supply fresh water to their residents? The answer is more ingenious than you might expect. From hidden systems to clever engineering, medieval builders found surprisingly advanced ways to keep water flowing in and out of these mighty fortresses. In the medieval world, water was more than just a basic necessity. It was the very foundation of life inside a castle. Without modern conveniences like faucets, pumps, or plumbing systems, access to clean, reliable water was a constant challenge. Yet, despite the technological limitations of the time, castles were marvels of ingenuity, carefully planned not just for defense, but for survival. And nothing was more vital to that survival than water. Life in a castle was hard. It wasn't all knights and banquets. Everyday existence involved constant labor, strategic planning, and a deep understanding of the natural environment. The need for water permeated every aspect of life. It was used for drinking, cooking, bathing, washing clothes, tending livestock, watering gardens, brewing ale, which was often safer than drinking water, and even making mortar for construction. Without a steady water supply, the entire system would collapse. Castles were often like miniature cities, housing hundreds of people, including soldiers, servants, nobles, cooks, blacksmiths, and sometimes even local villagers seeking protection. And each of those people needed water every single day. The importance of water became even more urgent during times of conflict. Castles were, by design, fortresses built to withstand long sieges, but a well-fortified wall meant nothing if the people inside were dying of thirst. In fact, many sieges throughout history ended not because enemies broke down the walls, but because the defenders ran out of food and water. That's why, from the earliest stages of design, medieval architects prioritized access to water just as much as they did towers and moats. Strategic placement of the castle was key. Many were deliberately built near natural water sources like springs, rivers, or underground aquifers. Some castles were even constructed around or on top of these sources, ensuring water could be drawn up from within the walls, completely protected from outside threats. In other cases, if a natural spring wasn't available, builders relied on deep wells or rainwater harvesting systems. Every option was carefully considered because the consequences of failure were deadly. But water wasn't just about utility, it had symbolic and cultural importance too. In medieval times, cleanliness was tied to morality, particularly in religious contexts. Monastic castles, or castles owned by deeply religious nobles, often had areas designated for ritual washing or even rudimentary bathhouses. Maintaining water access was not only a matter of survival, but also of dignity and status. Water also played a role in the power dynamics of the castle. The lord or lady of the castle had priority access to the cleanest water sources. They might have a private well, access to higher cisterns, or the freshest rainwater for bathing and cooking. Meanwhile, servants and common soldiers relied on communal systems or even had to ration water during lean times. In this way, water subtly reinforced the strict hierarchy that defined medieval life. All of this highlights one truth. Without water, a castle could not function, not for a day, not for an hour. And so, behind the towering battlements and grand halls, hidden from the eye of most visitors, was a carefully maintained infrastructure dedicated entirely to one thing: keeping the water flowing. This might not be the part of medieval history that gets the most attention, but it's arguably the most essential. Without it, the legendary strength of the medieval castle would have crumbled from within. To solve the problem of water access within the towering stone walls of a medieval castle, builders turned to nature and to remarkable engineering solutions that are still impressive today. Without electric pumps or municipal water supplies, the challenge was to bring fresh water in and keep it secure, especially in times of siege. The answer came in the form of wells, springs, and cisterns, clever systems built right into the heart of the castle itself. Wells were one of the most common and reliable sources of water. If a castle was fortunate enough to be located above an underground aquifer or near a natural water table, digging a deep well was a top priority. These wells were often located in the most secure parts of the castle, sometimes even in the courtyard or keep, where they could be protected during times of attack. Digging a well was no small task. It could take months, even years, of manual labor to bore through solid rock, inch by inch, sometimes reaching depths of over 100 feet. But the reward was enormous, a permanent and defensible source of fresh water that no enemy could easily cut off. The location of the well was strategic, but its construction was also highly sophisticated. Builders lined the well shaft with stone to prevent collapse, and sometimes built pulley systems or windlasses so that large buckets could be lowered and raised efficiently. In some advanced castles, counterweight systems or even animal-powered tread wheels were installed to make water retrieval faster and less exhausting. During peacetime, drawing water was simply part of the daily rhythm of castle life. But during war, that same well became the lifeline for every man, woman, and child inside the fortress walls. But what if a natural aquifer wasn't available beneath the castle site? Medieval engineers had solutions for that too. Some castles were built over or near natural springs, those rare places where water naturally bubbled up from the earth. A spring could be enclosed within the castle walls, or even rerouted underground to reach a central courtyard. In such cases, the spring became a constant, low-maintenance water source. These castles were often more resilient in long-term sieges, since the water essentially replenished itself without needing to be drawn manually. In mountainous regions or places with uneven terrain, water sources were sometimes found downhill from the main fortress. This posed a different kind of problem, bringing the water up to the castle. Ingeniously, medieval builders constructed sloped channels, underground conduits, or even early siphon systems that used gravity and water pressure to elevate small amounts of water to the desired location. In some cases, clay or lead pipes were used, primitive by today's standards, but remarkably effective. Yet another critical innovation came in the form of cisterns, massive underground storage tanks carved from stone or lined with waterproof materials. These cisterns collected rainwater from rooftops, courtyards, and gutters, channeling it into large, secure basins hidden beneath the castle. Cisterns were especially common in arid regions or high hilltop castles, where access to springs or wells was limited or non-existent. Every drop of rain that fell on the stone rooftops was seen as precious. Nothing was wasted. Rainwater harvesting wasn't just a backup system, it was a mainstay of castle design. Gutters and downspouts, often made of stone, wood, or lead, directed water from rooftops into storage tanks. These tanks were sometimes located directly below kitchens, washrooms, or even garderobes, toilets, allowing easy access where it was most needed. In winter, ice and snow were melted and stored. During long dry spells, or in times of siege, this stored rainwater could mean the difference between endurance and starvation. And then there were the more secretive and strategic uses of water storage. Some castles, particularly those in contested territories or near hostile borders, were built with hidden cisterns and concealed water tunnels. These allowed defenders to secretly access water even if their main source had been compromised. In a few rare cases, tunnels led all the way to nearby rivers, hidden by dense vegetation or underground passages. These escape routes and emergency water lines were often known only to the lord of the castle and a handful of trusted engineers or guards. In some sieges, this secret knowledge saved entire garrisons from surrender. All these methods, wells, springs, cisterns, rainwater harvesting, and underground channels, formed an intricate network of supply that worked quietly in the background of daily castle life. It's easy to overlook these invisible systems when we marvel at a castle's battlements or grand halls, but they were arguably more important than any wall or weapon. Without them, the castle would not be a fortress. It would be a prison. The genius of medieval water systems lies not in their complexity, but in their simplicity and efficiency. They didn't rely on power, electricity, or complex machines. They relied on gravity, stone, ingenuity, and a deep understanding of the land. These systems served generations of people through war and peace, drought and storm, all while hidden beneath the stones of history. They remind us that survival, especially in the medieval world, was not won by strength alone, but by wisdom, foresight, and engineering brilliance. One of the most remarkable features of medieval castle design was the way engineers harnessed the simple yet powerful force of gravity to manage water flow. Without electric pumps or pressurized plumbing, the natural slope of the land and the elevation of the castle itself became critical tools for transporting water from where it fell to where it was needed. In fact, many of the castles that still stand today owe their enduring functionality not only to strong walls and clever defenses, but to gravity-powered water systems that were both elegant and effective. The typical medieval castle was built on elevated ground, hills, cliffs, or man-made mounds, not just for military advantage, but also because higher ground allowed rainwater to move naturally downward. Builders took full advantage of this by installing a network of gutters, channels, and pipes that guided rainwater from the tops of roofs and towers into collection systems below. These channels weren't random. They were deliberately carved into the stone or assembled from wood, clay, or lead pipes. Over time, castle designers became highly skilled at planning these pathways to ensure that no drop of water was wasted. The rooftops of castles, especially the large sloped roofs of the great halls and towers, acted as massive rain collectors. When rain fell, water would hit these broad surfaces and begin to run down toward the edges. From there, stone gargoyles or carved spouts funneled the flow into defined drainage points. Gargoyles, in particular, served a dual purpose. They were decorative, often shaped like terrifying beasts to ward off evil spirits, but they also extended outward from the walls to carry rainwater away from the stonework and prevent erosion or water damage. Once water reached the base of the roof, it was guided into downspouts or open channels. These would be angled carefully to use gravity to move water across courtyards, through walls, and even into indoor reservoirs. Some castles had water stairs, stone staircases built at a precise angle so that water could trickle down them in a controlled flow, slowing the movement just enough to avoid erosion or flooding, but still keeping the water moving steadily toward its destination. In castles with internal courtyards, the central open area often served as a catch basin. These courtyards typically sloped slightly inward so that rain would flow toward the center, where grates or stone basins collected it. From there, water could be directed underground through channels to storage cisterns, or even flushed out of the castle via drainage tunnels if it wasn't needed. This design not only collected water efficiently, but also helped to keep the walkways and living areas dry and free of standing puddles, which could breed disease. Lead pipes, though expensive and labor-intensive to produce, were sometimes used in wealthier castles or monastic communities. These pipes could carry water horizontally or even down steep inclines without leaking, and they were often buried beneath stone floors or walls. The use of lead was not without consequence. Chronic exposure could lead to health problems, but at the time, it was one of the few materials that could be molded and sealed effectively for long-term use. In colder climates, the need to prevent freezing added another layer of complexity. Water channels and cisterns were often insulated with straw, cloth, or thick layers of stone to protect against winter frost. In some castles, warm air from fireplaces or kitchens was redirected through flues or stone vents to gently heat certain walls or passages, helping to prevent ice blockages in important drainage routes. The power of gravity wasn't only used for bringing water in, it was also essential for getting water and waste out. Once water had been used for washing, cooking, or cleaning, it had to be disposed of. This was achieved through sloped floors and waste channels that directed dirty water away from living spaces and into drains or cesspits. Again, gravity did the work. In some sophisticated castles, the kitchen floors were built with slight angles so that used water would automatically run toward a gutter at the edge of the room. From there, it would be carried through a pipe or channel out of the castle entirely, often into a moat or a filtered runoff area. This same principle was used in the management of toilets, known as garderobes. These were small rooms built into the thickness of castle walls, usually overhanging the outer edge of the fortress. Waste dropped down a vertical chute and was carried by gravity into a pit, a river, or the moat below. In more advanced cases, rainwater was directed into these chutes to help wash away waste and reduce odors, a primitive but surprisingly effective flushing system. Importantly, the use of gravity made these water systems reliable. They didn't require manual operation once set up, and they functioned continuously as long as there was rainfall or a sufficient elevation difference. This allowed castle residents to focus their energy on other tasks: defense, farming, food preparation, while the water system quietly worked in the background. It was low maintenance, durable, and entirely sustainable. What's most impressive is how these systems were planned long before construction began. Castle architects and engineers needed to understand the landscape thoroughly, how water moved across it, where the highest points were, where natural drainage occurred. They had to think like hydrologists centuries before that science existed. And once they chose the site, the entire blueprint of the castle, from tower placement to roof slope, was shaped around how to move and manage water. The success of these systems is evident in how many have endured the test of time. In some medieval castles that still stand today, you can walk along the original drainage channels, examine the slope of the floors, and see the stone-carved gutters still guiding rainwater just as they did hundreds of years ago. It's a testament to the wisdom and foresight of medieval engineers who understood that gravity, though invisible, could be one of the most powerful tools at their disposal. When most people imagine life inside a medieval castle, they think of grand feasts, towering walls, or sword-clashing knights. But few stop to consider the more uncomfortable realities, like where all the waste went. Without modern toilets, plumbing, or sewage systems, the issue of human waste could easily become a nightmare in the enclosed and crowded environment of a castle. Yet, once again, medieval engineers rose to the challenge. What they developed was surprisingly advanced for the time, a sanitation system that, though crude by today's standards, was incredibly functional, built around clever use of gravity, location, and natural water flow. These systems revolved around one iconic and often misunderstood feature of the medieval castle: the garderobe. The garderobe was the castle's version of a toilet, and it came in many forms depending on the wealth, location, and complexity of the castle. In its simplest version, a garderobe was little more than a small enclosed stone room built into the castle walls, with a bench and a hole cut through it. But this simple structure was ingeniously placed. Most garderobes were built to project outward from the main walls of the castle so that waste would fall down a vertical shaft or chute away from the structure, often directly into the moat, a cesspit, or a running stream below. In some cases, a secondary chute was carved into the stone wall itself, leading to a collection area hidden from view. The word garderobe itself is a bit ironic. In French, it literally means to guard the robe, and it originally referred to a place where clothes were kept. This was because the strong smell of ammonia from the human waste was believed to keep fleas and moths away, so some garments were indeed stored in these spaces, believe it or not. Over time, the term became more associated with the toilet itself than with clothing storage. In larger castles or wealthier households, garderobes weren't just added onto the side. They were built in clusters, stacked vertically through multiple floors of a tower or wall section. These vertical garderobes were often part of a dedicated latrine tower or chamber block, sometimes called a garderobe wing, where several people could relieve themselves in semi-private cubicles. Waste from the upper levels would drop into the same chute as waste from the lower levels, all funneled down to a single disposal area. It was an early example of a centralized sewage shaft. The disposal of waste varied depending on the location of the castle. In castles built above rivers or with access to flowing water, Guardrobes might discharge directly into the stream, allowing the current to carry waste away. This had obvious benefits for hygiene, though it could create downstream problems for other communities. In some castles, cesspits or waste tanks were built at the base of the chute. These pits had to be manually emptied, a job often left to the lowest-ranking servants or specialized workers known as gong farmers. Gong farmers would climb into the pits, often at night, and remove the waste using buckets and shovels. It was one of the most reviled but crucial jobs in the entire medieval economy, but not all guardrobes were exposed to the outside. In colder climates, or more fortified castles, toilets might be located deeper inside the structure, especially for nobles who wanted privacy and warmth. In these cases, the waste chutes would still rely on gravity, leading down into enclosed pits or out through the foundations of the castle. Some castles even had rudimentary flushing mechanisms. In rare and more advanced designs, rainwater collected from rooftops was diverted into the guardrobe chute during storms, helping to rinse waste downward and reduce odors. Though crude, this system was an early forerunner to the concept of a flush toilet. One often overlooked feature of these systems was the sluice, a narrow channel carved into the floor or wall to carry not just human waste, but also wastewater from washing or cooking. In larger castles, these sluices could run the length of a hall or corridor and were sloped just enough to guide dirty water toward a common drainage point. Combined with the garderobe chutes, this helped keep the inner castle relatively dry and clean, especially compared to the filthy conditions found in many medieval towns and cities. The strategic placement of garderobes also had a defensive function. Because they were often located on outer walls or built into small towers, they created weak points in the castle's defenses. Enemy soldiers could sometimes exploit these chutes, either by climbing up them or trying to break through the thin sections of wall where the garderobes were located. For this reason, garderobes were carefully placed, often high above the ground or in heavily guarded areas. In some cases, they were even designed with small defensive features, like murder holes or narrow arrow slits, just in case someone tried to sneak in through the toilet. The presence of these sanitation systems also reflected the hierarchy of the castle. The lord and lady would typically have private garderobes attached to their bedchambers, offering a degree of comfort and isolation. Servants and guards, on the other hand, often shared communal garderobes located in more exposed or less comfortable parts of the castle. Even in waste management, social class was reinforced. Over time, the knowledge and experience gained from building garderobes and waste channels evolved. By the late medieval period, some castles and monasteries had developed extremely sophisticated sanitation systems, complete with underground drains, water diverting mechanisms, and scheduled cleaning rotations. While we might laugh today at the idea of using a hole in a stone bench, these systems represented some of the most advanced hygienic thinking of the age. In fact, compared to the wooden outhouses and chamber pots still used in many homes well into the 18th and even 19th centuries, medieval castle sanitation was remarkably effective. It minimized exposure to human waste, controlled odors, and helped prevent the spread of disease in densely populated strongholds. It was practical, durable, and, most importantly, built to function under the constant pressure of medieval life, including the terrifying possibility of siege or war. Thus, while they may not be glamorous, medieval toilets were an essential part of castle life. They are a testament to the everyday ingenuity of a world that had to make do without the modern luxuries we now take for granted. And they remind us that even in an age of sword and stone, survival depended just as much on good hygiene as it did on good armor. In times of peace, the ingenious water systems of medieval castles functioned smoothly, collecting rainwater, drawing from wells, and managing waste through gravity-powered channels and guardrobes. But during a siege, when the castle was cut off from the outside world, surrounded by enemy forces, and under relentless pressure, these systems faced their greatest test. Water, which was always essential, now became a matter of life or death. Siege warfare was brutal, often designed not to breach walls by force, but to starve and dehydrate the inhabitants into submission. Castles that could maintain access to clean water during a siege had a real chance of withstanding prolonged attacks. Those that couldn't, they often didn't survive long. When planning for the possibility of siege, water was among the most critical considerations for castle architects. The first and most reliable method was to ensure that the castle had an internal well, a deep, secure well located within the walls, and ideally within the inner keep, was the gold standard. Unlike rainwater, which depended on weather, or surface springs, which could be diverted or poisoned by enemies, a deep well reaching into an underground aquifer could provide an uninterrupted water supply for months. These wells were often fiercely guarded, their locations kept secret or restricted only to trusted personnel. Some were concealed in locked chambers or hidden under trapdoors, especially in more paranoid or war-prone regions. However, even the best well had limitations. Drawing water was labor-intensive, and as the siege dragged on, the effort required to keep barrels full and clean became increasingly exhausting. To reduce dependence on wells alone, castles employed additional measures. Chief among them were massive rainwater cisterns and storage tanks. Before a siege was ever declared, the castle's inhabitants would begin stockpiling. Rain barrels were filled. Cisterns, huge stone-lined chambers often built beneath the castle floor, were topped off with every drop available. These cisterns were sometimes so large they could hold enough water for hundreds of people, and were designed to keep the water cool and relatively clean by limiting exposure to air and light. Cisterns were often connected directly to roof drainage systems, which funneled rainwater into them throughout the year. During dry seasons or drought, water from these cisterns was used sparingly. But when siege conditions began, every drop became precious. Inhabitants learned how to ration. Water for drinking was prioritized, washing and cooking water was reused when possible, and even waste disposal was adjusted to conserve every possible gallon. Yet there were always risks. Cisterns, if not well sealed, could become contaminated. Algae, insects, or even intentional sabotage could ruin an entire supply. It wasn't uncommon for spies or traders to try and poison the castle's water in the days leading up to an attack. For this reason, castle stewards often posted guards around water stores, even in times of peace. Every part of the water system, from well ropes to barrel lids, was subject to inspection and routine maintenance. The resilience of a castle under siege didn't depend solely on its soldiers, but on the forethought and vigilance of those who managed its supplies. In some particularly strategic or well-funded castles, additional innovations were developed. Secret tunnels, known as sallyports or postern passages, were sometimes dug from within the castle to outside water sources, streams, rivers, or hidden springs. These tunnels were narrow and dark, often just wide enough for a single person carrying a jug or bucket. They were dangerous, as enemy scouts might discover them, but in some cases, they provided a vital lifeline. There are recorded instances of castle defenders sneaking out under the cover of night to fetch water while under siege. If the tunnel remained undiscovered, it could be the reason an entire garrison survived. Another little-known method of water collection during siege was the use of natural condensation. In some castles, cloths were laid out overnight to collect dew, which would then be wrung out in the morning. This process was painstakingly slow and produced minimal amounts of water, but in desperate times, every drop counted. Snow and ice in winter months were also collected and melted for drinking and cooking. When fuel was available, large cauldrons were used to boil snow and purify it, a practice that required significant labor and firewood, both of which were often in short supply during a siege. But with all of these strategies, one factor remained constant: the need for discipline. Maintaining water supply wasn't just a matter of storage. It required strict management. A designated water steward or water warden would often be appointed, responsible for rationing water, preventing theft or misuse, and ensuring that the needs of the most vulnerable, children, the elderly, the injured, were met first. Rules were enforced harshly. Wasting water during a siege could be treated as a punishable offense, even treason, as it endangered the lives of everyone within the castle. The psychological impact of water scarcity during siege cannot be overstated. In the first few days, spirits might remain high. Defenders believed they could hold out. But as barrels emptied and the sound of dripping water replaced laughter in the halls, morale began to crack. The thirst set in, not just physical, but emotional. People became desperate, tempers flared, and trust was tested. In many sieges, the moment of surrender came not when the walls were breached, but when the last clean cup was drained. For attackers, this vulnerability was well understood. One of the most common siege tactics was to target the enemy's water. If a castle had an external spring or river supply, attackers would work quickly to block or poison it. Sometimes, animal carcasses or human waste were hurled into wells or water channels using trebuchets or catapults, an early form of biological warfare. The goal was simple: make the water undrinkable and force the castle to surrender without ever raising a sword. Despite all this, some castles held out. Their success was not just due to strong walls, but to smart water systems, careful planning, and the ability to adapt. These castles became legendary. They were spoken of in whispers by enemies who couldn't break them and written about by chroniclers amazed by their resilience. And while history remembers the generals and the battles, it is often the hidden stone cistern, the narrow tunnel to a spring, or the careful hand of a steward that truly won the day. Medieval castles were not merely monuments to war, they were living, breathing organisms designed to survive the most brutal conditions. At the heart of their survival was water, invisible, silent, and absolutely essential. In times of peace, it sustained life. In times of siege, it decided who lived and who fell. And the systems designed to secure it, ingenious, strategic, and quietly brilliant, remind us just how advanced medieval minds could be when survival was on the line.